Hello, I'm Matt. I'm going to be doing my extra credit video on the History of the Universe lecture that was given by John C. Mather. He's a Nobel laureate, first off, and it was very much of an honor to be in the presence of a Nobel laureate. And also at the same time, very, very uncomfortable. There are a lot of people in the same room. Most people actually did not even have a seat. They sat on the floor, but that's beside the point. It was very informative. He's most famous, John C. Mather, of course, for his work on the microwave background radiation that is observed at the edge of our universe, the observable universe. And the microwave background radiation is actually, it's an energy signature left over from the Big Bang that we can then use to discover more about the beginning of our world. The reason it's microwave radiation is it's so far away. The farther something in the universe is away from us, the faster away from us it's moving. So you've got this microwave background radiation 14 billion light years away. It's going to be moving very fast, so the wavelength of the radiation is redshifted to the microwave spectrum, so that's the reason that it's microwave background radiation, first off. Regarding the history, first of all, it's very interesting to think about the beginning of the universe, and interesting to think about the fact that stars didn't even form till 300 million years, they predict, after the universe was created. So you have this hot, dense, gaseous mixture of ions and subatomic particles just chaotically swirling about. No stars, no visible light at this point, so it's a very dark place. I just thought that was very interesting to think about. And of course all of this has been observed through Hubble. Hubble has given us great insight to the beginning, because the Hubble Space Telescope can see so far into space that it's really helped the scientific work of many great scientists. And he talked about the James Webb Telescope, which of course is not really a replacement for Hubble, but it's kind of an upgrade. You know, it's due to be launched, I think, in 6 years, 2018 or 2019, I believe is the date. Now, what's interesting about this, it's a telescope basically. So you got your telescope, and you have a sun shield, which basically shields the light from the sun to allow for better seeing, better visual when it's viewing deep into space. And this shield is actually the size of a basketball court, so I thought that was very interesting. There's a basketball court size sun shield helping the observations of a telescope out there soon. So I'm very excited to see that. Collision in the future of the Andromeda galaxy and our galaxy, the Milky Way, was also very interesting to me. It's going to happen in about 4 to 5 billion years, they predict, so obviously won't be around to see that. Hopefully humankind will, but obviously Earth will be long gone by then. The sun will have expanded and Earth will be burnt to a crisp. But actually have a video here. So as you can see, the two galaxies are gravitationally attracted to each other, so they're traveling towards each other at actually enormous speeds, but they're so far away, so it's going to take a very long time for them to meet. And it's actually very interesting that the stars are so spaced out throughout the galaxies, and spaced out, yes, that's a pun, obviously. It's cool to think that none of the stars will collide in the explosion because they're so spaced out. And obviously on this it looks like they will, but it won't. And so that's it. I'm right about at the 5-minute mark here, so cheerio. And I don't have a British accent.